up until now we've been looking at simple interest. Today we're going to look at compound interest. Now compound interest is probably the interest that you're more familiar with in any type of finance. It's much more common. So the only difference is, and I mentioned it briefly last week, is once some interest has been accrued, that basically adds to the principal, and then you find the amount of interest on that new value, rather than in simple interest where you're just finding the interest on the initial value. So we'll do an example. So calculate the final value of an investment of $6,000 at 8% per annum, compounded annually for 3 years.
So you don't have any sticky tape on there, do you?
No. The initial amount that you have is $6,000. Now each year it's going to earn 8%. So what we're going to do first is we'll work out the interest after 1 year. Then we'll have some new amount. Then that new amount is going to earn 8% the next year. And then we'll have some new amount, and then that amount is going to earn interest the third year. So you can split it up into 3 different sections. So we'll go year 1. Now remember, lowercase I we've been using to represent interest rate. Capital I we've been using to signify the interest earned. So if it's earning 8% interest in the first year, I'm going to say interest is equal to, so I just need to find 8% of that 6,000. So remember, 8% as a decimal is 0.08 times 6,000. So that value comes to $480. So now this is where the compounding comes into it. So it's earned 480. So that 480 is now going to get added to the principal. So imagine you got a bank account, you had 6,000, it earned $480 of interest, and now in your bank you've got $6,480. So year 2, now the interest is going to be 8% of, not 6,000. We have to add the interest that it made. So we're going to find 8% of 6,480. I might just make a note here. Therefore, what are they? New balance is equal to, so after it earned $480, the new balance was 6,480. Then in year 2, we're going to find 8% of that, so 0.08 times 6,480. So can you see the difference between this and the simple interest? With the simple interest, rather than finding 8% of the new amount, it was still just finding 8% of the initial amount, and then it would have added it to the total. But now we're finding the percentage of that increased balance. So 8% of that is $518.40. So the new balance is going to be what we had in the account, 6,480 plus it just made $518.40. So you'd add those two together, and it comes out to 6,998.40. So $6,998.40. Now remember, this was happening over 3 years. So then in the third year, the account is going to do 8% of that number. Now notice in the first year, the interest accrued was $480. The interest in the second year, is it more or less than that? More. So this is why compounding becomes useful in investment, because if you continue to create interest on a larger amount, it actually starts to grow exponentially. So now, our third year. So now we're finding the 8% of our last balance, which was this amount here. So you would assume, again, that the interest is going to be more than it was before. So the interest comes out as $559.87. So therefore the new balance is what was in the account before. Then it's earned that much interest, so it's going to be that plus that. 6,998.40 plus 5,559.87. And that comes out as 7,558.27. So our final balance after 3 years is that amount. So part A asked for the final value, and then part B is how much interest has been accrued. So our final value is this much. So A, final value is equal to 7,558.27. And then B, if we wanted to know how much interest was made on our $6,000, you just simply subtract 6,000 from that final balance, and then that will show you how much interest was accrued. So total interest is equal to 7,558.27 minus 6,000, which will be 1,558.27. Opposed to, if it was simple interest, it would have just been 480 times 3, which is 1,300 and something. So it's less than that much. So you can see when it compounds, the amount gets larger quicker. Now, it's not useful, well, if we wanted to know what that amount was after 25 years, it would be really annoying to have to keep doing that, right? To have to go year 3, work out the interest in that year, blah, 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 blah. So there's actually a formula that we can use to determine what interest or how much interest has been accrued over a longer period of time. So just here. So the future value of an investment, FV, is equal to the initial amount times 1 plus I. Now the interest rate again has to be written as a decimal to the power of n. And so we'll just write this formula down. So FV, well actually I won't write it, you guys just write this. FV equals PV, and then I'll show you how to use it. And make sure you actually label what each of those different things are. Are you writing this, Jaden?
Yeah.
Alright, when I check your book at the end of the lesson, if it's not, you'll be doing it then at lunchtime. Yeah. Alright, you prefer to do it at lunch, fair enough.